y value, our up, down, our left, right. So this is just a made-up triangle in this bottom right. It just says if I give you 2 points, x sub 1, y sub 1, x sub 2, y sub 2, how do you get the distance from P to R? So if I look at the distance from P to R, the only thing that will change is your x value, how far left or how far right you are. So we'd say a distance would be something like x sub 2 minus x sub 1. Now, the problem is, hey, in every math book, they say x sub 2 minus x sub 1. It doesn't matter because we don't know which one's our first point and which one's our second point, nor do we know which one's bigger or smaller. They're arbitrary. So what we typically do is we put absolute value bars around it to say, hey, if I picked a smaller one first, I'm just telling you it's got to be positive. So if that distance turns out to be negative 3, I just make it a positive 3 instead. Well, the only difference from Q to R is the height. So those are our y values. So in most math books, we have y sub 2 minus y sub 1 to get that distance between those. So that's how I get the distance if they're straight across from each other or straight vertical of each other. Now, I do want to stress the point out, when I teach this in an algebra class or something, I don't care which one of these comes first. You can go x sub 1 minus, they're arbitrary points. So I put my 2x values in, subtract them, I got my distance, subtract these, and I got my distance. Well, that gets further to say that, well, that forms a right triangle if I connect them all, which means I can use a squared plus b squared equals c squared instead. In other words, this side squared plus this side squared has to equal this hypotenuse. That's the length I'm actually looking for. So consider this black line that length that I'm looking for. Well, that's why I said, oh, hypotenuse squared equals leg squared plus leg squared. But I know 2 of these values, hypothetically. I hypothetically know these 2 values where my PR equals this, so I'm going to throw that in there. And I'm going to throw this one in there. Now, a small fact that is often overlooked. When you square something that's got absolute value bars around it, you can get rid of the absolute value bars. Because what do absolute value bars do? They make it positive. What happens if I square a negative? It becomes positive. So when I throw these in there, I'm going to get rid of the absolute value bars. That's where they went. So right now we have basically our hypotenuse squared equals that first length, which was x sub 2 minus x sub 1 squared. Once again, I got rid of the you could put them in there. They're just redundant. And that'll be plus our y, which is our QR squared. So that's y sub 2 minus y sub 1 squared. Now, all they said is the formula typically states the distance between these points equals something, not the squared of it. So what they tell you to do is basically take the square root of both sides, and we're going to come up with the distance between any 2 points on the Cartesian plane is going to equal the square root of your x values subtracted and squared plus your y values subtracted and squared. And this is typically just a formula you memorize, but it's also a formula you can derive every time you forget about it. That it really is just a squared plus b squared equals c squared, but I moved the square root to the other side because I'll know all of these numbers. Is that a little clearer?
Yes, I'm trying to figure out the square root.
Yep. We're not getting tested on this. We're getting tested on knowing the Pythagorean theorem, but this will be good for when you get to, maybe you didn't take Algebra 2 yet, in Algebra 2 when they come up with this, or pre-calculus when they come up with that as well. Okay? Yeah, go. I could do one of them. Do you have a preferred one, 17 or 18? 17. All right, 17 says, I'm given 2 legs. I need to find a hypotenuse. Well, I need to find one that will make it acute, and I need to find one that would make it obtuse. So I need one that's too small and one that's too big to actually be a hypotenuse. So the first thing I should do is, I should go, well, if I was asked to make this a right triangle, we'd have to go, c squared plus 9 squared equals kind of that c squared. This would be if I wanted to be an actual hypotenuse. So solving this down, can you help me out here real quick? I want to practice on our calculators. Oh, you can't do it that quick. Everyone take a second and do 6 squared plus 9 squared. I want both of them. I want 6 squared plus 9 squared. I want the whole thing added. What'd you come up with?
117.
117. 117. We're looking at 117. So we have 117 equals c squared. So if the question is, what is the hypotenuse to make this a right triangle, we'd go, oh, c would have to equal the square root of 117. Can someone help me out and plug this in your calculator and give me an approximation? Give me it to like the 10th.
10.8.
Yeah. 10.8?
I kind of remember it from last.
Did we get 10 point? Anyone else get 10.8?
Yeah, it was 10.8.
Okay.
So it has to be between 10 and 11.
So this is, I forgot who asked, Santiago, you asked this question, right? So this would be perfect if I want to make this a right triangle. If it said, make it a right triangle, what does your third leg have to be, or your hypotenuse? It has to be the square root of 117. That wasn't the question. The question is, what would that length need to be acute? That was our first thing. A says, what value would you need to make it acute? Well, to make it acute, I just need something less than 10.8. So I can make it 10.7. I can make it 10.6. I go ahead and I make it an even 10. Because if it's 10, Santiago, so this is a right triangle. If it's too small, it makes it acute. So I'm just shrinking what would make it a perfect right triangle to make it acute. Now, to make it obtuse, I need one that's slightly bigger. So I'm going to pick 11. But you could have picked 10.9. You could have picked 11.5. You could have picked 12. As long as it doesn't make a right triangle and it's bigger than what would make a right triangle.
Would a right triangle be if they were both the same?
It'd be a right triangle if it was square root of 117. That would make it a right triangle. So if I said, and think about this as one of the problems that were on there. If I gave you a triangle with a leg of 6, a leg of 9, and I asked you to find the hypotenuse, you would just plug in this formula, right? This formula finds a hypotenuse of a right triangle. Making it smaller makes it acute. Making it bigger will make it obtuse. Will that help you on the next one?
Yes.
Cool. Yeah. 14. 14. The cool thing about 14 is we really don't need... Hey, we're going to find other ways to solve this. Talking about today, that 45 is an interesting technique. But really, all we needed was this. They gave you extra information. They tried to throw you off by making it kind of a square shape. Actually, a rhombus. Oh, it would have been a square. So if I look here, I can see that these are congruent, which means base angles are congruent, which means this is 45 degrees, which means this must be 90 degrees. You need to know how to do that. You need to know how to find that 90-degree angle. I don't need to put any more drawings in here because this is my right angle. This is my hypotenuse for this. So I'm going to go leg squared plus leg squared equals hypotenuse squared. The thing is, both my legs are the same, but I'm still going to write them in. My leg 1 is x, so I'll have x squared plus my leg 2 is x squared needs to equal 6 square root of 2 squared. Tracking so far? Okay, when you add things with the same base and the same exponent, you can add those. Like if I give you an x squared and I give you another x squared, you have 2x squareds. Remember that number in front is telling you how many you have of something. So I have 2x squareds
12 squared root of 2.
is going to equal, what was that?
12 squared root of 2.
Not 12 squared root of 2. I think you multiplied by 2 instead of, because this should be 6 squared times square root of 2 squared. So that would be 36 times 2, which would equal 72. So we have 2x squared equals 72. Common mistake. I see it all the time. That's why I always write it out fully. I don't ever skip this step. I always write it out fully because it's an easy mistake to make. All right, now we divide both sides by 2. And we'll have x squared equals 36. We're going to take the square root of both sides, and we're going to come up with x equals 6. Do you think it's a coincidence that this is 6, 6, 6 square root of 2? Not the 666 part, but the fact that it's the same number, same number, same number square root of 2. That's going to be an important lesson today. That's what we're going to learn about today. Any other questions? Yeah, go.
Number 20.
20. All right, some dude. Okay, a walkway forms one diagonal of a square of a playground. So we have a square playground. So we have a square playground. Let's go ahead and draw that. And the important thing about a square is all the sides are the same length. Oof, that's an intense. So we have a diagonal. A walkway forms the diagonal of a square of a playground. So all sides are the same length. So x, 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 x. Okay. The walkway is 24 meters long. So this would be 24 right here. This would also be a right angle. To the nearest meter, how long is the side of the playground? So this falls into the same camp as the one we just did. And the fact that we have a right triangle, so we can go x squared plus x squared equals 24 squared, and we just solve for x the kind of the same way. Is that going to be enough for you?
Yeah.
Okay, cool. Go ahead. 21. 21, I can really forget about all they're talking about. They're saying the Hubble telescope orbits 600 kilometers above Earth's surface. Earth's radius is about 6,370 kilometers. Use the Pythagorean theorem to find the distance x from the telescope to the Earth's horizon. Round your answer to the nearest 10 kilometers. So we just need to look at this picture. There's one thing we need to add to this picture. I know this distance. This is unknown. This is what I'm solving for. And I know a chunk of this distance. Well, we have to realize that this circle must have the same value over here. So we're going to go ahead and we're going to copy and paste this 6370, and I'm going to paste it right here, 6370. Which means this total length right here is going to be 6,970 kilometers. Now the only thing I have to do is I have to do this squared. This x squared plus this squared equals this squared. It's going to be a good exercise in using our calculator because I don't think we're going to be doing that in our head. But then you're done after that. Is that far enough? Cool. Anything else? Yeah. 10, we have a three-dimensional shape. I'll walk you through my thought process. I would like you to do this. So I'm going to go ahead and I'm going to name this maybe y, and I'm going to name this one z. I need to know both of these values in order to find x, because this would be y squared plus z squared equals x squared. So I need to find both of these. I need to use the other right triangles to find these. So for instance, for this triangle right here, I'm looking at this triangle right here. Can you picture that triangle? It's got a hypotenuse 17 and a leg of 8. That we would have 8 squared plus y squared equals 17 squared. I'm going to stop for a second. I'm going to go to the other big triangle that we need to know. I'll highlight that one in pink. That one has a hypotenuse of 10 and a leg of 8. So this triangle right here, I'm going to go ahead and solve. Well, that's 8 squared plus z squared equals 10 squared. So I'm going to take my time, make sure I solve for y, make sure I find z correctly, and I'm going to have to do the Pythagorean theorem one more time to find that x. Is that enough to get you at least started?
Yeah, I just know how to set it up.
Yep, perfect. Any other questions?
No,
Yeah.
I had a question on number 4. Number 6.
Number 6? A specific question?
No, just the whole thing.
Just the whole thing? All right, so we need to first figure out if it's a triangle. It might be a good idea to get approximations for these first to see if it's a triangle. Can you guys help me out? What's the approximation for square root of 7 if you type that in your calculator? 2.6. What's square root of 11? 3.3. Is it 3.9 or is it 3? 3.3? Okay. All right. So if I'm just rough estimating to see if this is going to make a triangle, we're going to say, okay, 4 is my biggest. So I would do something like, okay, 2.6 plus 3.3. Yeah, that's bigger than 4. I'm good. Good there. It can be a triangle. I'm just checking to see if it's a triangle.
Yeah, but I did it.
The only way to check to... The only way to check to see if it's a triangle is you take your two smaller sides and see if it adds more than 4.
Yeah.
That's it. All right. Now to figure out what kind of triangle this makes, we still have to do a squared plus b squared has something to do with c squared. I usually put the longer side first. I always put the hypotenuse first. So I'm going to go, okay, 4 squared has something to do with square root of 7 squared plus square root of 11 squared. So it's the same thing we did on all the other ones. This time we just have square roots in it, which makes our life a little easier because square root of 7 squared is just 7. Square root of 11 squared is just 11. So the only one I have to do is 4 times 4 is 16. Has something to do with 7 plus 11, so that's 18. 16 is less than 18. This 4 was my potential hypotenuse. My potential hypotenuse was too small, so it makes it acute.
Okay.
I didn't.
Okay, yeah. I just did this first, probably. Yeah.
Exactly.
All right, any other last second questions? All right, just because we started class really late, we're really late, and we had lots of questions. We're going to skip bell work for a second. We're going to go right into today's lesson. If we have time, we'll go back to it, and we'll talk about what the answer should be. All right, today we're going to talk about 2 specific triangles. So up until now, we used the Pythagorean theorem. The Pythagorean theorem required you to use 2 sides. You needed 2 sides to solve it. Special right triangles, you only need 1 side to solve it. There are only 2 special triangles we're going to learn. We're going to learn 45, 45, 90, and we're going to learn 30, 60, 90. You need to know these. These are very, very important ones for this class. So 45, 45, 90, 30, 60, 90. In fact, you just got to remember 90, 45, 90, and either 30 or 60 because it has to work out the rest of the way. All right. It works. We'll put it in further. Is it better? All right. Okay. So, if you have a 45, 45, 90 triangle, you will not be using the Pythagorean theorem. Instead, what we're going to realize for a 45, 45, 90 triangle, you're going to have 2 legs that are congruent. Just like that problem that we had x, x, and the hypotenuse. So we have 2 sides that are the same. Now, I use very specific notes on these. You can change the variable if you want to. I use s's and not x's because x's show up too many times in problems and it confuses people. So what I do is I label both of these as s's. You can pick a completely different variable if you want to. I just pick s stands for side. So I'm going to say my leg is S. If your leg is S, that will automatically make your hypotenuse S square root of 2. Automatically. Which means you will not be doing the Pythagorean theorem. So as soon as you find out one of the legs of a 45, 45, 90 triangle, you're going to know your hypotenuse right off the bat. If this was 9, this would be 9 square root of 2. Yes. Remember, we don't know those values yet. It's our job to find those values. So that's our thing. Now, remember, you don't have to use s's. S's can be confusing because I just don't like using x's because x's show up all the time and it can confuse people. Because what we're going to do is when I get to a problem like this, we know this is 45, 45, 90 because this is 45, this is 90. If you do 180 minus 90 minus 45, that leaves you with 45.
So do you label it as?
So what I'm going to do is that's what I'm going to do. I'm going to point to each side and note what variable I would use there. So hypothetically, I would say that this is my S, this is my S, and this y will be my s square root of 2. Your job is to circle the one that points to a number that can help you solve this. That s goes to 8. That tells you your s variable for this problem is 8. So what I'm picturing right here for this problem is s equals 8. That's our key to the rest of them. Because I said oh, you know what? X just equals S. So X would equal S, which equals 8, which means X equals 8. Y equals S square root of 2, but S equals 8, so I throw that 8 in there, and my Y equals 8 square root of 2. Does anyone else kind of feel like it was a waste of time writing all those S's and stuff, and I'm like, oh, I could just put it there, I could put it in there? I got you. But there's a reason why I do this. I don't ever just do this to waste your time. It becomes harder when I give you the hypotenuse. So let's label this one the exact same way, but notice which one we're pointing to. So we know the one across from the 45s. Those are my S's. So when I solve for S, I'll have my Y value and I'll have my X value. I don't know either one of those. Your hypotenuse for a 45, 45, 90 is S square root of 2. So this 19 right here is S square root of 2, and I'm going to circle that because that's the key to this triangle. That S square root of 2 has to equal 19. This was super easy because I knew S equaled 8. It pointed right to it. This is an equation I have to solve. I right now know that S square root of 2 has to equal 19. But I need to know what S equals to plug it in here. So I need to solve for S so I can plug them in here, which means I need to divide both sides by square root of 2. So I'm going to divide both sides by square root of 2, which will give me S equals 19 square root of 2. Does anyone see a problem with having S equaling 19 over square root of 2? Santiago. Square roots in a denominator. Can someone else raise your hand and tell me how do I get rid of a square root in a denominator? Elmer.
Multiply the denominator?
Yep.
With the numerator?
Yep. Multiply the denominator and numerator by that square root of 2. So I'm going to go ahead and say, okay, multiply this by square root of 2. Multiply this by square root of 2. And my S value will equal 19 square root of 2 over 2. How long is X then? Yeah.
19 square root of 2.
Yep. How long is Y?
19
Over 2. Yeah. So now we know X and Y are both the same, so I can go X equals 19 square root of 2 over 2. And I can go Y equals 19 square root of 2 over 2. So do you have to label these triangles S square root of 2? No. But I find it the easiest way, especially when that hypotenuse is listed. And it's going to help you too because we have one more special triangle we have to worry about, and that's 30, 60, 90. So I highly encourage you to label them just like I did. People that do that typically get these correct. People that do it in your head typically get it wrong. It just happens. All right, does that make sense? So that's if I see a 45 degree and a 90 degree. Now our next special triangle is what happens if I have a 30, 60, 90? Well, that means I have a 30 and a 90 or a 60 and a 90. So you'll notice on these I have a 60, 90, a 30, 90. That makes it fall into the 30, 60, 90 camp. We'll find those missing angles and find out it is 30, 60, 90. This one's more complicated because I have 3 different things to worry about. I have the side that's across from the 30 degrees. I will note the shorter leg is always opposite the smaller angle. Smaller angle versus bigger angle. A smaller angle is going to open less than a bigger angle. So this is always going to be our short side. The one across from our 30 is going to be our short side, and we're going to label that with S. So our short leg is just S. Just like on our 45s, this is the one across from our 45s, the one across from 30 is going to be S. The next easy one is our hypotenuse. Our hypotenuse is going to be 2S. So that seems pretty easy. That is 2S. The one across from our 60 is the hardest one to get, and that's going to be S square root of 3. S square root of 3. I always remember 3 because we have a 30, 60, 90, 33. The other one has s square root of 2 because you have two sides that are the same. This one has 3 sides that are different, so it's s square root of 3. Your biggest mistake people are going to make is they're going to confuse that s square root of 2 and this s square root of 3. You need to realize s square root of 3 goes with your 30, 60, 90. So our longer leg is going to be our s square root of 3. Okay, so if I have a problem like this one, our first one, this is probably the easiest one you'll get. You'll note that we have a 90, a 60. That means this leftover one is 30 degrees. Has to equal 180. Has to. So the one across from our 30 is our short side. Ooh, I want to go to my next slide so I have a little bit more room. The one across from our 30 is our short side, so that's going to be our S. My S equals 5. That makes it as easy as you can make it because now we can just plug it in. The one across from our 90 degrees is our 2s. Whoop, that looks like SS. 2s. The one across from our 60 is going to be our s square root of 3. But like I said, anytime that s goes right to our number, those are the easiest ones. Because can someone tell me the length of y? Raise your hand and tell me what's the length of y. Oliver. It's going to be 10 because we're going to have 2 times 5, which equals 10. Someone besides Oliver, can you tell me the length of x? Okay. It'd be 5 square root of 3 is correct because we take that s and plug it in, so it'd be 5 square root of 3.
How do you get the
What was that? How did I get y?
like you do 2?
Why? Because notice how I circled this one. S equals 5, right? So that means if this is 2s, it'd be 2 times 5. That's why I have the 2 times 5. So once you solve for s, your job is just to plug it in those variables. Does that make a little more sense?
Yeah.
All right. This can be really confusing, and all of a sudden you just get it. It's kind of one of those things. It can be really, really confusing. It just takes practice, and all of a sudden you get it, and you're just like, I don't know why I didn't know it before. All right, this is where it gets a little bit more difficult. Notice we have 30, we have 60, and we have 90. This is probably the hardest one you can do for 30, 60, 90. Because the one across from 60 degrees is our s square root of 3. The one across from our 30 is our s. The one across from our x is going to be our 2s. Circle the one that points to a number. That's your key to solving the rest of them. So I now have s square root of 3 equals 14. So I'll go ahead and do that. S square root of 3 equals 14. I need to solve for s. Someone raise your hand and tell me, how do I solve for s? Joseph.
Divide both numbers by square root of 3.
Yep, so I'm going to have s 14 square root of 3. Someone besides Joseph, what would I do next? Because that is not simplified. Yeah.
Multiply the square root of 3.
Yep, top and bottom, right? Top and bottom. So if I multiply that top and bottom, square root of 3 times square root of 3, I'm going to end up with s equals 14 square root of 3 over 3. Well, that's my s. So that's not an answer. That's just what my s equals. That will get me to my answers, but we got to be careful here. We know y just equals this. Y equals s, s equals this. So we know what our y value is. Our y just equals 14 square root of 3 over 3. Now be careful when you get to x. X equals 2s. So I need 2 of these. I need 2 times whatever my s is. So we're going to have 2 times that 14 square root of 3 over 3. That 2 doesn't cancel out with that 3, so that 2 is going to go on top and make this 14 28. So 2 times 14 is 28. It doesn't affect that square root of 3. Multiplication just affects one number. So 2 times 14 would be 28. So x is going to equal 28 square root of 3 over 3. What are we going to do to the bottom, I guess? What was that? It can't make it 6 because 2 has to go to the top. Remember, 2 is actually 2 over 1. So when you multiply fractions, our top goes to the top, our bottom goes to the bottom. So that 2 will only go to the top. It doesn't go to both things. That would be if it was 2 over 2, it would go to both things. So 2 just goes to the top. Questions on those? We'll find out. We got 6 of them to do. We'll work on them within our pods. So work together, help each other. We're going to do these top 6 within our pods. If you get to that last one, awesome. Otherwise, we'll meet up and we'll do that last one. Yeah, got to go to the bathroom? Yeah. If you just want to abandon your pod. If you were stuck on a couple of them, make sure you ask questions. All right, so the first one. I know this is a 45, 45, 90 triangle. 45, 45, 90 means label it S, S, S square root of 2. So your S's are the ones across from your 45 because both of these are the same size. So I know if I find X, I have Y. My 28's across from my 90 degrees, this is my S square root of 2. So we now have to go, you know what? S square root of 2 equals 28. Divide both sides by square root of 2. You come up with S equals 28 over square root of 2. If you're terrible at simplifying, leave it. You're going to lose a little bit of points, but not a ton. All right, so right now I do know that X and Y equal 28 over square root of 2. It's just not simplified. So to simplify it, I multiply the top and bottom by square root of 2. When I multiply the top and bottom by square root of 2, guys, I get 28 square root of 2 over 2.
I thought it would be over 28. What?
Not over 28 because the only thing we're moving up top is the square root of 2. We're not moving the 28 down. Yeah. Okay, now we should simplify this a little bit because what's 28 divided by 2?
14.
14. So this is actually going to be 14 square root of 2. And that is my S value. S equals 14 square root of 2, which means Y, which equals S, is 14 square root of 2. X, which is S, is 14 square root of 2. So both of those are 14 square root of 2.
Could you simplify it even more?
You cannot simplify it any further. That is fully simplified. I'm not sure what you did, but you did something wrong if you went further.
Well, yeah, like, since you simplified it, never mind.
No, it's good. All right. So our next one, we now have a 60-30. For a 60-30, we locate the one across from 30 degrees. That is my S. The one across from my 90 is my 2S. The one across from my 60 is my S square root of 3. This is a nice problem because if 2S equals 16, so let's circle that. If 2S equals 16, what does S have to equal?
8.
8 is correct. Now, we could write it out or you could do it in your head. I'll write it out because I circled it. So 2S equals 16, so S equals 8. Our job is to take that 8 and plug it in there and to plug it in there. Y equals S, so Y equals 8. X equals S square root of 3, so X equals 8 square root of 3. It's easy once you start practicing it. You got to practice it, though. You got to practice it so you don't get on the test and you write S's everywhere and you have no idea what they mean. All right, for the next one, we have a 45, 45, 90. This is like the best one to get because the ones across from 90 degrees are our S's. Anytime they give you the S value, your life is pretty sweet. So in this case, S equals 4. What does X equal then?
4. No.
Yep, you're right. X equals 4. And Y equals 4 square root of 2. Are we good with those? Are we okay if I skip to the hard one? Okay, so I'm going to skip to the hard one. I'm going to skip to number 7. I'm going to skip to number 7 because I'm going to change things up a little bit. First of all, I'm going to wait for people to stop talking. And the second thing is I have 2 triangles I need to solve. Because notice how this triangle has 1 side and this one has 0 sides? I need to solve this one first. This is a 30, 60, 90 triangle. So we have a 30, 60, 90 triangle. So what I'm going to do is I'm going to do the same thing. I'm going to say 60, 30, 90. Hey, if it's across from 30, I mark it as S. If it's across from the 90, I mark it as 2S. And if it's across from the 60, I write it as S square root of 3. Let's solve this triangle. So this triangle tells me that S equals 9. Are we on board with that being S equals 9? For this triangle only, S equals 9. So what does Z equal? What does Z equal? Z equals 2S, so that would be... Are we good with 18? 2 times 9 would give me 18. So from this right here, I'm going to come up with Z equals 2 times 9, which is 18. Got one of my answers. Now, this S square root of 3 is this side length here. What is this side length then? Yeah. 9 square root of 3. So what I'm going to do is either scratch it out, or I'm just going to replace that S with 9, because now I know that value. Now I know that length. Here's a bit of advice for you. Don't use S's again, because it might confuse you. Someone give me a variable. Give me a letter. Y. Well, let's not use Y, because we have Y and X up there. F. I heard F. So I'm going to, so it's 45, 45, 90. I'm going to label this as F, F, and this is going to be F square root of 2. Because notice now I'm on a 45, 45, 90. So that's our S squared of 2, but I picked F's so they don't confuse me with the other S's. Does that make sense why I switched variables? Are we okay? Okay. So I'm going to point to the fact that I now know F square root of 2 equals 9 square root of 3. So now I'm on this bottom triangle. So I'm going to put a little box here to say that was for that work up there. Now I'm on to this triangle here. Well, I know F square root of 2 equals 9 square root of 3. How do I move that square root of 2 to the other side? Divide, multiply, divide. I'm going to divide both sides by it. So that's going to give me F equals 9 square root of 3 over square root of 2. Are we allowed to have square root of 2 in the denominator? No. So this is probably the hardest problem we've had because I have to multiply top and bottom by square root of 2. As a reminder, when you have 2 square roots multiplied, you need to imagine it as being under one big square root. So square root of 3 times square root of 2 is square root of 3 times 2, which is going to be square root of 6. So this problem is going to be 9 square root of 6 divided by 2. Y and X are both the same value. So can someone raise your hand and tell me what's the length of Y? Santiago? What was that?
3 square root of 6.
One more time.
3 square root of 6.
3 square root of 6. I don't think 3 square root of 6. I didn't do 3 square root of 6. Oh, did you think this was a 3?
Oh.
This is a 2.
Oh.
This is a 2. We can't simplify that any further. So you want to change your answer at all?
9 square root of 6 over 2.
9 squared is 6 over 2. Yeah, we can't simplify that because that's not a 3. I think you just divided by 3, right? All right. So we now know that Y equals 9 square root of 6 divided by 2. Then I'm going to ask the hardest question of the day. Raise your hand. Tell me what X equals. What does X equal on this one? Raise your hand. Don't shout it out. One person knows it? I asked the easiest question of the day. Arson. Same thing. 9 square root of 6 divided by 2.